So you'll see that in those prior examples, they were all in, each of the equations were in standard form. There was something x plus or minus something y equals some number, like this right here. X, then y equals a number. Whereas this is in slope-intercept form. If you have one equation of each in your system, substitution's likely the easiest way to go. Now you could add 2x to each side of the equation to turn this top equation into standard form, and then you could use the elimination method. But otherwise, instead, we can just say, hey, wherever we see a y, we can put this in place of it in the other equation. So in this other equation, I see a y right there, so I'm going to put this whole part into parentheses, the negative 2x plus 13, in place of it. So it'll look like this, negative 7x plus 6 times, so it's not just 6 times y, it's 6 times, well now y is all of this, 6 times negative 2x plus 13 equals negative 17. So this equation that I just wrote looks very similar to this one, except for this goes in place of the y. The 6 still comes down, the equals negative 17 still comes down, and so does the other term of negative 7x. So then from here, folks, you're going to simplify and solve. So we get negative 12x. We have to distribute here. Negative 12x plus 78 equals negative 17. We can combine some like terms. Negative 19x plus 78 equals negative 17. And then we're going to subtract 78. So we're solving for x now. What's being done to it? How do we undo it? We undo adding 78 by subtracting 78. So we get negative 19x equals negative 95. That sounds right. Yeah. And then solve for x. Divide by negative 19. A negative divided by a negative is a positive. So we get x equals positive 5. That was a lot of work. That's what x is. Well, now we need to find y, but it's actually pretty sweet. If you go back to the one that's in slope-intercept form, you can easily plug this 5 in place of x right here in the highlighted region. So negative 2 times 5. Oof. I put a dot and it looked like a minus sign. So there we go. Negative 2 times 5 plus 13. When you crunch that out, that equals 3. So y equals 3. So x is 5, y is 3, right here. And you could check down here by just plugging in quickly in your mind or on your calculator, putting in 5 for x. So negative 7 times 5 is negative 35, plus 6 times 3 is 18. Yeah, boom, that equals negative 17. Check with your calculator. Boom, that's totally right. Let's try it again here. So wherever I see a y, I can substitute in 4x plus 7 in place of it. So I'm going to put that in place of this y in the other equation. So negative 8x minus 5, not times y, but negative 5 times 4x plus 7 equals negative 7. I continued with the rest of the equation after I substituted in for y. So then careful here, folks, this is a negative 5 that we're distributing. And it's just in the parentheses. So we get negative 20x minus 35. To finish off what we have here, drop down the negative 8x plus and drop down the negative 7. And now combine like terms. You get negative 28x minus 35 equals negative 7. What's being done to x? We're subtracting 35, so add 35. We get negative 28x equals 28. So x equals negative 1. Now plug that negative 1 in place of the x in that other equation that we haven't used yet, and you'll see it's very quick and easy to simplify. So negative 4 plus 7, that's 3. Y is 3. So that's my answer. You can check it again in this by just taking -8 times -1 minus 5 times 3, all on your calculator. As long as it knows the order of operations, it should spit out a -7. That's totally correct. Why don't you try those last two? Ooh, Mr. P didn't throw any graphing on here. You're lucky. We'll have to try that some other time.